All right, Harmony Science Academy students, AP Calculus. Let's go ahead and get into section 4.5, Integration by Substitution. Okay. Long story short, if you look back at our U substitution, it was meant to take a complex-looking problem and make it simpler looking. Okay. So this is not an exception. We've got 5 scenarios coming up. There's 4 practice problems for each scenario, so 20 in total. And then at the end, some review, like always. So let's go and get into it. This number 1, express each definite integral, right? You're like, oh yeah, that's definite integral in terms of U, but do not evaluate. So we're going to perform this, and you must at the end look at it and be like, oh yeah, it's easier looking. Okay, so you can perform whatever easier. Okay. All right. So as soon as see here, they identified U for us. Okay, which is nice. If they hadn't, it should be pretty easy for you guys down the line to identify U's. At times it'll be more complex with more advanced problems. That's fine. Here it's given, so this is U. Okay. The logical thing to do is identify du, derivative of U. So you look at it, and you know it's that. Okay. So here we have U in terms of x, du in terms of dx. Okay. All right. So now let's go ahead and rewrite this as best as we can. Okay. So here we have the interval in terms of x, so we'll address that in a bit. It's not in terms of U. But for right now we have what? We have this portion is U squared. Okay. And we have a negative 6x. Okay. All we need is a 2x dx. So I'm going to put the 2x here. Okay. Now, since I have a 6x, I only need a 2x. I can toss in that extra factor out there. Okay, so that's what gives us 6x. And that negative that we don't need, we'll go ahead and bring it out here. Okay. And, well, we had a dx, so we still have a dx. Okay. So now if you guys look, I have my u, and this here can be replaced with du. So, we've got negative 3. We have, I guess for now we'll put, okay, all right. So looking good. So we've got our function in terms of u, but this interval is still in terms of x, okay? So what's the workaround? Okay, there's that constant, the integral. Cool thing is they don't want us to evaluate. That's going to save us time, because once you get here, I know you should be able to perform it. You've done it before. So here's the last step, okay? So this is in terms of x. All you have to do is go and plug it in here, okay? So negative 2 gives us in here a 4 plus 2 is 6. And let's take this guy. Plug him in here. 1 squared plus 2 is 3. Okay? And I guess technically, I'm stuck here again. See here. Alright, I can't access certain menu items, that's fine. So we've done this part. They're going to kill us to go a little slow here. And then if we go one more, we can basically write it like this. The integration of negative 3 over u squared du. And of course our interval with respects to u. Okay? Alright. So you guys will go ahead and have 2, 3, and 4 to kind of practice on. So let's go and continue. Alright. Now we're going to do 5. Right? We'll do this set. So these say evaluate each indefinite integral. You want to get comfortable with identifying definite and indefinite. I'm sure most of you guys do. So let's go ahead and attack number 5. Alright, so we're going to integrate 6x squared over 16 plus 4x to the 6 dx, okay? Use substitution. Now, sometimes it might seem unnecessary, but this is a skill you just want to get good at, okay? So let's identify u. Right, u is, and the tip here is you definitely want to look at the formula chart, okay? So here, without the formula chart, okay, you can get lost in the sauce pretty easy here, okay? So again, pause the video, take a look. So the wisest thing we can do is go with 2x cubed. Okay. Now some of you guys might be thinking, do I really need the u? Just wait and see, okay? So now we have du, right, which would be the logical flow is 6x dx. Okay. Now, again, this is indefinite, so we don't have an interval. We're going to have a family of integrals. Okay. So let's go ahead and do exactly that. Okay. Now, if you guys already found the formula, you'll know that this one should also be, is ultimately going to be a squared, which is 4 squared, plus, very importantly, u squared, okay, which will give us this. And I need to embed a, what? Whoops. I just noticed 2x cubed should be what? 6x squared. Okay. Alright. So 6x squared dx, 6x squared dx. Notice that in this case my du is already embedded there perfectly, so I don't have to factor out anything. Okay. So we can just call this du. And because it's ready to go, we can simply complete the process, okay, of integration. So that means, according to a formula chart, I'd have 1 over a, okay, would be arc tangent. So you can write arc tangent or tan inverse, okay, and it'd be u over a, okay, so 2x cubed over a, okay, which is 4. Right? And the plus c in this case, why? Because we do have a family of functions. So go and take a look at that, and let's move on to the next one. Okay, and before we move on, in case you guys aren't very clear, you can also write it in this notation, just in case it pops up, okay? Alright, so that part's important, especially if you weren't super confident with that, okay? Alright. Let's go to number 9. This is the third set here, okay? We're going to integrate 60x cubed over 3x to the 4th minus 5 dx. Okay, so essentially it's the same process here. So let's go ahead and identify u. And let's go and pause the video here and give you a chance to kind of scope out the formula chart. Okay, if you got tripped up, I'm with you. If you identified that this is actually related to the basic differentiation rule number 9, u prime over u, good for you, okay? So let's first identify u in this case, which is and du, which would be what? Let's see if I can squeeze it in here. It would be 12x to the 3rd. Dx. Okay. Alright. So now let's go ahead and apply it, I guess, right? Write it in terms of u. So here we definitely have u. Okay. du is 12x cubed dx. So almost, right? So I'm going to go ahead and write 12x cubed. The dx is there, of course. And I notice that I have a factor of 5 in addition to, okay? So notice that how I'm addressing this now, I can do what? du over u. And with these, again, we're not evaluating, so we can go ahead and finish it off and describe it in terms of u completely, which would be 5 u du. Okay. Alright, so I'm actually thinking about number 1 where we were asked not to evaluate. With these we are, so basically it just means to integrate, okay? So I guess this portion we can kind of disregard. Okay, we can go ahead and take care of this. Now again, we're looking at basic differentiation rule number 9, which tells us that what, right? Again, inverse operations are antiderivatives and derivatives. So how would we proceed here? Right, basically just apply it. It's the natural log of u. Okay, so this is this portion right here, and we've got this bad boy. Okay, so let's go and have 5 natural log and plug it back in here. U is exactly that. Okay, then kind of pause, jot that down before we move on. If you caught on to the plus c portion, good. Since it is indefinite, we are producing a family of integrals, and there it is. Okay. So again, what you should be appreciating is the fact that you can't be sure that you can account for everything, but if you set it up in this u du form, pull out whatever, pretty much whatever factors are not necessary, you can integrate comfortably and then address and put everything back towards the end. Okay. All right. Let's go to the 4 out of 5 sets. Okay, or the 4th out of 5 sets. So that would take us to 13. Okay, so let's go ahead and hit it straight. Integrate 20x to the 4th times 4x to the 5th plus 1, that raised to the 5th dx. Okay, so there's a lot going on here. Okay, so hopefully by now you've bought into the fact that, hey, you know what? If I can perfect this u, I can pretty much integrate anything. That's the right attitude. Okay, so let's go ahead and identify it as 4x to the 5th plus 1. Okay, and down here du is obviously 20x to the 4th. Alright, so let's go ahead and start rewriting this bad boy in terms of u, right? So we're going to have definitely u to the 5th. Okay, and I need 20x to the 4th. Actually, it's already there. Whoops. Okay, dx. So it's all set up for me, right? So what would the power rule have me do here? Okay, basically have u to the 6th over 6. And now let's go ahead and plug it back in. What is u? Oops. I can't access that, darn it. So let me... Actually, it wasn't there, it was over here. Right. Sorry. Okay. There we go. My brain's waking up now. So now we can go ahead and apply 4x to the 5th plus 1. That over 6 plus c. Okay, you can pause, jot that down, and kind of tutor me, right, if I need it here. Alright, and before we move on, if you caught this missing exponent of 6 up here, that means you're right on point. Okay, appreciate your help there. Let's go ahead and move to 17, right? This is the 5th set of 5. So again, let's be honest. Let's look at it for what it is and be like, OMG, right? How are we going to do this? Now, hopefully your confidence in this u substitutions just grown exponentially. So let's identify, again, just with that rhythm, right, that we've developed, it should be pretty obvious by now how to identify u. Okay, and of course in a math class, typically u's going to be put right in front of you, right? Real world context would be a different scenario, but for right now, we can rest easy. Okay, so this is 8x cubed dx. Okay, all right. So you can pause it here and kind of attempt to proceed on your own. So let's go ahead and continue here. So we're going to integrate, and 8x cubed, right? So I've got an additional negative 4 that I'm going to factor out. Right? So I have the 8x cubed cosecant squared of what? U dx, right? So here's this portion, so now I can take the negative 4, integrate, and we've got cosecant squared u du. And here, of course, you can pause the video and scope out that formula chart, okay? Alright, so if you're looking at, what number is that? Basic integration formula number 13. You're right on point. So we've got negative 4, which turns into negative cotan of u. Okay, we'll just put u for now. Let's see. Okay, I need some space here, so we've got negative 4. Or rather, I can go back. So I'll deal with that in a bit here. Cotan u is 2x to the 4th plus 3. Let's see, and finally, we can write it as just 4 cotan 2x to the 4th plus 3. Let's see, producing our family of integrals. Alright guys, appreciate your time. We'll catch you in the classroom for, for practice and a Q&A session, okay?